Hey everybody, this is Mr. Longo, and in this video we are going to graph rational functions by hand. Yes, that's right, I said it by hand. I will allow you to use your graphing calculators to check for now, just to be helpful as you get used to this, but we're going to do this by hand, so prepare your minds to be doing a lot of thinking, okay? So, in the previous video, we talked about how we find all of these different asymptotes and intercepts and holes and all that. Today, we're actually going to apply it. And we'll do it one step at a time as we think our way through each one. Okay? So, step one is always to factor the function if it can be factored. So this is going to become 3 times x minus 3 over... and this would factor to x plus 3 times x plus 3, which means we have 3 times x minus 3 over x plus 3 squared. Remember, squaring a term sometimes has an effect that you need to work on. So, first thing was the hole. The hole is where two of the same terms cancel on the top and the bottom. You cannot cancel an x minus 3 with an x plus 3, so there are no holes. So you would simply write none. X-intercepts. Remember, your x-intercepts is when you set your numerator equal to 0 and solve. So, if we had 3 times x minus 3 equal to 0, divide both sides by 3, we have x minus 3 equals 0, and that's going to become x equals 3, so our x-intercept is 3, 0. I want you to notice it is odd, which means it's going to cross through. Remember, if it's a multiplicity of 2, that's where it bounces. So now that we found 3, 0, we are going to go place 3, 0 on the graph right now, so we don't forget about it later. Y-intercept. Remember, with the y-intercept, that's when you substitute in 0 for all x's. So that's going to give you 3 times 0 minus 3 over 0 plus 3 quantity squared. And that, of course, is going to give you a negative 9 over a positive 9, which means our y-intercept is 0, negative 1. And we are going to go plot that bad boy right now, 0, negative 1. And we're going to keep this nice and color coordinated for you guys. Now, your vertical asymptote is when your denominator is set equal to 0. So, we have x plus 3 quantity squared equals 0, which means I want you to notice it is even, and that has an effect. Square root both sides, you still have 0, so subtract 3 from both sides, and you end up with x is equal to a negative 3, which means it is even, which means they approach from the same side. And last up is, well, first we're going to go graph that. X equals negative 3. Remember, it is a vertical asymptote, so we graphed a vertical dashed line. And the last one is our horizontal or our oblique asymptote. This one is bottom heavy, or the degree in the denominator is higher. We have x to the first on top, and we have x squared on bottom. Remember, when it is bottom heavy, it is y equals the number off to the side. Well, there isn't one, which means it is y equals 0. It doesn't mean there's none. It's y equals 0, which is the x-axis, so we're going to put a horizontal dashed line right through the x-axis. Now, I want you to notice there is an x-intercept, which means this is going to be one of those examples where the graph crosses a horizontal asymptote. So, what you want to do is use the given points that you have to come up with the first part of the curve. So since it's going to cross at 0, negative 1, we know this first part of the branch is going to look a little bit like this. And again, it is allowed to cross but it will follow that horizontal asymptote the rest of the way through. So now we have to go to the other part. This is where your x equals -3 is even comes into play, because when the vertical asymptote is even, they approach from the same direction. Now there are no other x-intercepts, so this guy's not going to cross the horizontal asymptote, and that's how we sketch that graph. Now if you were to type that in your graphing calculator, you would see that's what you're going to get. Okay? Next one. Why don't you pause the video and give this one a try and see if you can come up with the correct graph. Okay. Whole. There is none. Again, nothing canceled. None. X-intercepts. So if you set the numerator equal to 0, for your x-intercepts, you should have come up with a -4, 0, and you should say that it is odd, which means it crosses. And your other one should have been 3, 0, which is also odd, which means it crosses again. So you should have a dot on -4, 0, and 3, 0. Your y-intercept, that's where you substituted 0 in for all of your x's, and that would have given you 4 times a -3 over a 2 times a -2, which is going to give you a -12 over a -4, so that is 0, 3. So you should have a y-intercept at 0, 3. Vertical asymptote. Your vertical asymptote is going to give you x equals a -2 and x equals 2. These are both odd, which means they come from the opposite direction. And the last part is your horizontal or oblique asymptote. Since this is equal degree, that is where you take the leading coefficient. So if you were to FOIL this out, you would have x squared on top, x squared on bottom, no numbers, so that's 1 over 1. Your horizontal asymptote is at y equals 1. So we have to plot our x equals -2, vertical line, and our x equals a +2, vertical line. And then we have our horizontal asymptote at y equals 0, or 1. I'm sorry, y equals 1. So now we have to do that thing where we think about all directions. There is no x-intercept in between here, and we can see that the y-intercept is above, so this is going to look a little bit like that, where it doesn't cross any of the x-intercepts. It doesn't cross the one in the middle because it never has an x-intercept between -2 and 2. The odds tell you these come from opposite directions. So if this guy's coming from the top, this one's going to be coming from the bottom. It has to cross through the -4, but it will not cross that because we're approaching opposite directions. This one's going to do the exact same, and boom. That's what you should have had. I understand it's tricky. There's a lot to think about, but if you break it down into the steps that we talked about in our last video, you will be okay. All right, there is one more, and I know you haven't seen a hole yet, so you're probably thinking this one's going to have a hole, and you will be correct. So remember, when you are doing these, the first thing you need to do is simplify. So those x plus 1s are going to cancel. If you would like to try this one again on your own, just click pause and give it a try. Click play when you're ready. Okay? So this one would simplify to x plus 2 squared over x plus 3. So our hole is where those guys canceled. So the x plus 1 is set equal to 0, and you solve, you get x equals a -1. But then remember, you plug the -1 into your simplified equation and evaluate. So, -1 plus 2 is 1 squared is 1 over -1 plus 3 is 2. So you have a hole at -1 comma 1/2. So you are going to -1, 1/2, and you're going to put a circle. And it could be a little bigger than you think because we're working with a small graph. No big deal. X-intercepts, you set your numerator equal to 0. So we're just going to set our x plus 2 equal to 0, and we're going to get -2 comma 0, but this time it was even, so it's going to bounce. Okay, so at -2, 0, that is going to be a graph that bounces. Y-intercept, you plug in your 0, and you get 0 plus 2 squared over 0 plus 3, which means you are going to get 4/3. So you have a y-intercept at 0, comma 4/3. Obviously, that's just a little bit bigger than 1, so anywhere a little bit above 1 is going to be fine. Next up, our vertical asymptote. Our vertical asymptote is where you set the denominator equal to 0, so you have x equals a -3, and that is odd. So it's going to come from opposite sides. So we're going to go to x equals -3. We're going to put a vertical line, and you should see by now you have enough information to kind of see what one side is doing. But now we get to the fun part. This is top heavy, which means you do synthetic division. So what you have to do for this part is take your x plus 2 squared, and you have to FOIL that out, getting x squared plus 4x plus 4, and that's going to give you a 1, 4, 4 that we're going to use synthetic division with. We're going to divide by a -3, giving us 1, -3, 1. So that's y is equal to x plus 1. And we're just going to give that guy a little sketch right here. And all you have to do from here is connect the dots in the way you think they should be. Since it is odd, it is going to go like that. Okay, that's it for this video. This is Longo and I'm out. See you, bye.